The world of physics is filled with terms that often confuse those outside the field. While familiar, these terms frequently have meanings that differ from their everyday usage. Many were chosen to create vivid mental images or for convenience, but they can mislead those trying to understand the underlying concept. Take the term black hole. It evokes an image of a literal hole in space that might suck in surrounding objects. In reality, a black hole is not a hole at all, but rather a region of spacetime where gravity is so intense that not even light can escape. The name highlights its light traffic nature, but fails to capture its true physical nature. The Big Bang suggests a massive explosion, but it actually describes the expansion of space itself. The universe didn't explode from a central point into empty space. Instead, space itself began to stretch from an extremely hot and dense state. Fred Hoyle coined this term ironically as a critic of the theory, but its catchiness made it stick. Spooky action at a distance. Einstein's description of quantum entanglement describes how two particles can become linked, so their properties are instantly correlated regardless of distance. While the term captures the phenomenon's strange nature, spooky misleadingly suggests something supernatural rather than a well-understood quantum mechanical process. The electron cloud conjures images of a hazy mass, but it's actually a mathematical description of where an electron is likely to be found. It represents a probability distribution, not a physical cloud. While helpful in visualizing electron position uncertainty, the metaphor can lead to misconceptions. Spin in quantum mechanics has nothing to do with actual rotation. Instead, it describes an intrinsic form of angular momentum that particles possess with no classical equivalent. The term was chosen for its connection to classical angular momentum, but this can cause confusion about its true nature. The weak force, despite its name, is actually much stronger than gravity and plays a crucial role in radioactive decay. Its name comes from a comparison with a strong nuclear force, showing how scientific terminology often reflects relative rather than absolute properties. Virtual particles describe temporary quantum field disturbances that appear in calculations, while virtual suggests they are not real. These particles have observable effects. The term reflects their fleeting nature, but misleadingly implies they are purely fictional rather than essential components of quantum field theory. These terms, though imperfect, have become fundamental to physics communication. They demonstrate how scientific language, while sometimes misleading, can help bridge the gap between complex concepts and public understanding. If you enjoyed this video, please give it a thumbs up and subscribe to my channel. Thanks for watching.